Welcome back again. Welcome back again to another topic, that is the algebraic expressions from 2. Algebraic expressions from 2. So I'll be doing the questions from the year 2010 all the way to the year 1999. I think up to there you'll have gotten the concept and able to tackle any. The year 2010 says 4x minus 9x cubed all over 3x squared minus 4x minus 4. Lana, as this is calling for 3 marks. 3 marks. Once you find a question with a number on top and a number on bottom, and once we have a question with a number on top and a number on bottom, please try to treat it as a numerator and a denominator. Let us try to exist it as a numerator and a denominator. We cannot. A numerator and a denominator. Sorry, Lana. Sorry. So we'll do the numerator and again tackle the denominator. Then overall we'll now do the numerator over denominator. What does our numerator say? 4x minus 9x cubed. Once you see an expression with 2 parts, look at whether part A is squared and part B is squared, and find whether you can go on and look for this. A squared minus B squared is originating from M plus B into A minus B. A minus B. For example, 4x and 9x cubed, that is not a perfect square, but we can as well find what is common. Between 4x and 9x cubed, we can say x is existing on all the sides. After deducting x, here we remain with 4 and 9x squared. Good. Square root of 4 is 2, square root of 9 is 3, square root of x squared is x. So this is a perfect square. It fits here. We can simply say it is x into square root of 4 is 2, square root of 9 is 3, square root of x squared is 9, and again 2 plus 3x. The numerator is done. The numerator is done. What about the denominator? 3x squared minus 4x minus 4. I want 2 numbers, x and y. When I multiply, I get part 1 and part 3, which is 3 times negative 4, negative 12. But when I add these 2 numbers, I'll have to get negative 4. What you do, Lana, you go for the multiples of the multiplication. So multiples of 12, we have 12 and 1, 6 and 2, 3 and 4. Look at all these numbers, which seems to have a difference of 4 when you add or when you subtract. It gets to 6 and 2. To get the minus 4, it means it will be minus 6 plus 2. When you add 2 to minus 6, you get minus 4. Why are we finding the numbers that we will replace for minus 4, that gets us to negative 4? This simply means you will replace the minus 4 with the 2 numbers. How do I mean? What do I mean? 3x squared minus 6x. Instead of writing the minus 4x, we now write this minus 6x plus 2x minus 4 is equals to 0. In every 2, pick what is common. 3x squared and 6x. The numbers 3 and 6 share 3. X squared and x share x. So 3x squared divided by 3x, we get x minus 6x divided by 3x, we'll get 2. Okay. Plus 2x and 4 will share what? 2x and 4 will share 2x and 4 will share 2 into x minus 2. Why minus? Minus times plus gives us minus, Minus times minus gives us minus times plus gives us minus. So it will be 3x plus 2 into x minus 2 into x minus 2. From there, learner will now do something called overall, that is numerator over denominator. Numerator over denominator. Our numerator said what? X into 2 minus 3x, 2 plus 3x, all over 3x plus 2, x minus 2. Look at what is common. If you land up your question having something not common on the numerator and the denominator, definitely you are wrong. For example, here we have 2 plus 3x, here we have 3x plus 2. So this one is similar to that. We simply get x times 2. We can leave it as x into 2 minus 3x all over x minus 2, or outdo the bracket by multiplying it with what is inside. It will simply take us to 2x minus 3x squared all over x minus 2. 3 marks, x minus 2. These questions simply need something very simple. Very key. Finding the numbers very key, and also finding those sums that go for this rule of algebraic expressions is another key. That is 2010, very easy, 3 marks. No careless mistake, being very keen, you end up getting it very right. You end up getting it very right. Now, another question says, simplify the expression, 3 marks. We have x squared plus x minus 4xy minus 4y all over x plus 1 into 4y squared minus xy. As we have said earlier, we now do the numerator, denominator, and do an overall of the numerator of the denominator. Okay, let us see. The numerator says x squared plus 4x minus 4xy minus 4y. Once you see the expression with 4 parts, 1, 2, 3, 4, it calls for grouping. In every two, pick what is common. X squared and x share x. So x squared divided by x. X squared is simply x times x divided by x. You will remain with 1x. Okay. Then x divided by x will remain with 1. Okay. 4xy and 4y share 4y. So minus 4y into, here we remain with x, minus times minus gives us a plus. 4y divided by 4y we get 1. What is outside the brackets? Let it exist on its own bracket. It will be x minus 4y into x plus 1 into x plus 1. Okay. So this becomes our numerator. Let us go ahead to our denominator, x plus 1 into 4y squared minus xy. Learner, if you have a problem with multiplying expressions, I'm here to help you. Pick part 1, multiply with everything in the next bracket. It will be x into 4y squared minus xy plus 1 into 4y squared minus xy. Good. How to do the bracket? 4y squared times x will be 4x y squared minus x times x, x squared y plus 4y squared. Is it plus 1 really? What did I do? Yeah, it is plus 1. 4y squared plus times minus. Plus times minus will be giving us minus xy. I've said, when something has 4 parts, please group in terms of 2 what is common. For example, here we can see x is common and y is common into 4y minus 1, okay, minus, not 1, minus x, 4y minus x plus, what is common there will be the y into 4y minus x into 4y minus, sorry, Lana. Now we are on the same page. Allow me to regroup this. How? The 4's to exist on the same page. 4x y squared plus 4y squared minus x squared y minus xy. So what is common here will be the 4 and y into 4y squared into x plus 1 minus, again what is common there? It is the xy into x minus times minus gives us a plus 1. Xy divided by xy in 1. So this denominator ends like 4y squared minus xy all over into x plus 1. X plus 1. As we said earlier, we now do overall, that is numerator over denominator. What does our numerator say? X minus 4y into x plus 1 all over 4y squared minus xy into x plus 1. Those ones end like that. We remain with something like x minus 4y all over 4y squared minus x y minus x y. Good. That is our final ends. So that is another similar 3 marks. Multiplication of the algebraic expressions is very key. Pick one part, multiply with everything in the next bracket. Pick the other part, multiply with everything in the next bracket. Remember, sign of a number always occur before the number. Sign of a number always occur before the number. Always occur before the number. Now we have another question that says, this is from the year 2008. This says 12x squared plus ax minus 6a squared all over 9x squared minus 4a squared. This is ax. So as obvious, we'll now start by the numerator, denominator, then overall. Numerator says 12x squared plus ax minus 6a squared. Pick those two numbers, x and y. When I multiply them, I get part 1 and part 3, which gives us negative 72. But when I add the numbers x and y, I get positive 1. Which are the numbers when I multiply? I get 72, and the difference between the numbers is 1. Definitely minus 8 plus 9. Why have I written opposite signs? Because Minus times plus gives us a minus. So instead of writing plus ax, we write minus 8ax plus 9ax. So it will be 12x squared minus 8ax plus 9ax minus 6a squared, giving us in every two, pick what is common. 12 and 8 share what? 4. X squared and ax share x. Here will just remain with 3x minus 8 divided by 4 is 2. Ax divided by x becomes a plus. Third sign will always repeat itself down here. 9 and 6 share 3. Ax and a share a into 9 divided by 3, 3. Ax divided by ax. Okay. Why am I putting a minus? Minus times plus gives us a minus. 6a squared, 6 divided by 3, 2. A squared divided by a will give us an a. So the numerator gives us 4x plus 3a. 4x plus 3a into 3x minus 2a. That is our numerator. Our denominator becomes 9x squared minus 4a squared. Lana, as I have said before, once you find that the sum has two parts, look at whether you can get the square root of everything there or whether there is a number you can outdo to remain with the perfect square. What is the square root of 9? 3. Square root of x squared, x. So this gets the perfect square we are talking about. It will simply be a squared minus b squared is equals to a plus b into a minus b. Square root of 9, 3. Square root of x squared, x, plus square root of 4, 2. Square root of a squared, a. It is done, learner. So that is our denominator. Our overall will be numerator over denominator. Our numerator says 4x plus 3a into 3x minus 2a all over denominator, which is 3x plus 2a, 3x minus 2a. Look at what is common and cancel it off. We'll simply remain with 4x plus 3a all over 3x plus 2a. 3x plus 2a. 3x plus 2a. I'm about to end this session. I'll be back. I really need to take some tea, Nana. So I'll do 2 more questions and call it a day. Then we can meet in our next session on the same. I am sure you have not understood well. So I'll be back. So a power 4 minus b to power 4. A cubed minus ab squared. I've said once you find that it has 2 parts, that is, for example, a to power 4 minus b to power 4. Are we able to get the square root of 4? Yes. So we'll now be going for a minus b, a plus b, or a plus b, a minus b. Square root of a to power 4 will be a to power 2 plus square root of b to power 4 will be b to power 2 into a squared minus b squared. Good. And we know a squared minus b squared is the same as a squared plus b squared into a plus b, a minus b. Square root of squared is a squared is a. Square root of b squared is b. So I hope you have gotten the reason as why I have broken it. Okay. The other one says a denominator says a cubed minus ab squared. We got to know a perfect square of a cubed. So we have to do a because here there is an a and here there is an a. A into a squared minus b squared. So this is the same as a into a plus b, a minus b. Again, our numerator ends there. So our numerator of our denominator will be a squared plus b squared into a plus b, a minus b, all over a into a plus b, a minus b. A plus b, a plus b, a minus b, a minus b. So our answer becomes a squared plus b squared all over a, all over a. Thank you, Lana. Up to there. I beg your pardon. We'll be meeting in our next session and tackle the remaining and even add more. Please internalize that. Ensure you look for those things with two parts that are separated by a negative. That calls for perfect square. The formula a squared minus b squared is equal to, has been gotten from a plus b, a minus b. Again, if there are two numbers separated, if there are two parts separated by minus, find what is common that you can outdo and remain with the perfect square, or remain with the final option of that part. Thank you, and we'll meet in our next session. I wish you a nice evening. I wish you a nice evening. I wish you a nice evening.